Hello everyone, my name is Christy Walsh, and today I'd like to talk to you about a defect decision system that I've made for inspector and plant personnel to use when presented with what could be a defect in a piece of pressure equipment during a turnaround. Here's a video that I've captured the high-level scope and intent of a typical turnaround. All this equipment that you see here, plus a multitude of more, are used in the processing of oil in order to make fuel for your vehicles. As these pieces of equipment are used, they start to deteriorate. Planned plant outages, also known as turnarounds, are performed every 3 or 4 years so that the equipment can be cleaned, inspected, and repaired if needed. To give you an idea of how big a turnaround is, there is one that I worked at a few years ago in the smallest refinery in North America. It produces only 12,000 barrels of fuel a day. To contrast that, a large refinery produces 300,000 barrels a day. This small one lasted 21 days. We inspected 300 pieces of equipment, and it cost $17 million. Time, cost, and safety are critically important for a successful turnaround. As there's very little time to make a decision, and the wrong decision could become very costly, it's important to do the right thing when presented with what you see pictured here, a linear indication. To be honest, this could be a big deal, or it could be nothing at all. As soon as you find a linear indication, it's important to make the right decisions so that you aren't doing more work than what's needed, and vice versa. The consequence of not repairing it correctly could result in fires and people getting hurt. Given that time is so critical, I decided to make a defect decision system. Each step leads to further work or evaluation until you get to a decision. The outcomes during a turnaround could be grind and report, repair, or replace. Replace could be the component, or it could be the entire asset, depending on the circumstances surrounding it. Exampled here is taking you through the decision process to understand whether or not to repair a linear indication. You'll note that in this scenario, the answer is yes. So who would use this system? Why and when? Well, ultimately it would be first used by inspectors, and then depending on how the decision system went, it would be operations, and then potentially procurement. When could the system be used? It could be used now and into the future. And why would an organization want to use it? Well, it really sequences the steps required. It's repeatable decision steps, which provides consistency, and each step is exhausted before the next. So the benefit to that is stakeholders know that each decision step has been exhausted and that their role is simply to support the next step. I decided to focus the expert system on one aspect of the work that I do because of the systematic approach that can be applied. I looked for information largely based on my experience, and for the purpose of this exercise, I will reluctantly call myself the expert. The only technical issue in using expert rule is not being able to use the dialog boxes as I expected to. I accommodated by creating images with text. I can see the industry moving towards systems like these and making decisions as turnarounds get more systemized, more costly, and as more inspection data is obtained and analyzed. I see a decision system would be quite disruptive at first, as it is a change to the way things are done, and people generally don't like change. In order to be adopted by the industry, rigorous testing would have to be performed. The benefits of this system include getting the decision system to ensure that all appropriate avenues are explored and that only the work needing to be done is performed. This will result in reduced costs, improved safety, and improved reliability. Thank you for your time.